up and we should be able to hear you. Okay, great.
So, okay, so what it is I'm doing right now is I just have my, okay, well, anyway, I've got my camera enabled, so.
Yeah, okay. So when
so
it's your turn to speak, Anna is going to be able to put your face on the screen so everyone will be able to see you. And I think we have you coming up first, so it won't be that long.
Right, okay, very good.
Oh, okay, thanks.
No pressure, but just, you know. Like, no pressure.
No pressure. All right, everyone. This is louder than it usually is, but I hope it's not too loud. Thanks, everyone, for coming tonight. Welcome. We have a special event tonight where the Northwest CPP group, Northwest C++ group, and the Seattle Rust user group are getting together for a joint meeting. Lloyd here has come up with a fantastic idea about, what, six or 7 months ago?
Yeah.
That we started, on the idea and working on it and putting it together. And here we are. I think you're going to have a lot of fun, we hope. Let's get started. So we're operating under the Microsoft Reactor Code of Conduct tonight, and it's very straightforward. It basically asks us to each treat each other with dignity and respect. If you find that
except for the panelists. The panelists are allowed to, call each other names and stuff.
maybe the panelists can get into it a little bit with each other.
We all signed waivers.
That's true. But if you're not able, if you're feeling like somebody's not treating you with dignity and respect, please let them know. And if the situation continues, please let either Lloyd or myself know, and we will step in to help out.
I'm immune, so feel free to abuse me as much as you want.
So for those in the Rust group who don't know, the Northwest C++ group, NWCPP, you can visit their website. For anyone who's either new for tonight or doesn't realize, the Seattle Rust user group has a Discord server. If you go to that link, you can join and chat with folks afterward. This slide deck, which will contain all the slides for all the presenters, is available at slides.com, U007D. And we have some news. This will be for both the Rust group and the Northwest CPP Club, the last meeting at the Microsoft Reactor for a while. So it's a beautiful facility, but just given the environment we're in right now, they're not hosting live events here for the foreseeable future. So we are both, is that correct? Both in search?
We are both looking for a new home.
Both looking for a new home. So if any of you know of a good place, I think both of our goals is to keep our groups free of a charge to, the attendees. So if you guys know of a place that would be compatible with that, please reach out. We'll have an after event gathering, and you can let us know there, or you can reach out to us online. But sadly, we won't be meeting here for the foreseeable future.
Yeah. Oh.
Mm-hmm.
Yep.
Yeah, the comment is that maybe the King County Library system could be of service, and we've looked into it. It's not quite as straightforward as we might have hoped, but yeah, we're happy to chat about this.
I could address that in a little more depth if you'd like.
Do you want to do that right now, or do you want to get into the presentation?
I'll just make one sentence. So yeah, we're looking at the King County Library system. We're also looking at Crossroads Mall has a community room. Community centers have a community room. So I'm kind of looking around at those. If anybody knows of one offhand that's a good fit, reach out to Brad or myself. There's actually, ironically, a good one right by me, but it's so badly located for everybody else, it's not usable. And then at least for the C++ group, we'll be meeting on Teams. I'll put a Teams site up, so we'll continue to meet. We'll just be remote until we find a new home. And I think you're probably doing the same thing.
Yeah. For work, I love remote, but for this stuff, I much prefer being in person. And, we'll talk on Discord, whether we want to take a pause and then resume when we have a place, or whether we want to continue to meet online. But sitting in front of Zoom for 2 hours is not exciting. I'm just going to put it out there. Anyway, we'll figure it out.
Yep.
All right. There is an after-meet gathering. And as the Rust people know, we stole the idea from the C++ group to meet at Red Robin. And it's all ages, and we could get everyone in, and it was great. They have space. They accommodate us putting all the tables together. They let us shut the place down. They're really nice. It's great. So yeah, thank you guys for that. And but tonight I think we should
just
all
to be sure, which Red Robin?
I'm about to go there. Yeah, that's
Thank you.
perfect. That's perfect. So just for tonight, we're actually going to do the whole joint thing. So CPP folks, come join us at the Redmond Town Center, not the usual one where you guys meet, but at the one at the Redmond Town Center. And it'd be great to have an even bigger table tonight. So everyone is invited to meet at the Redmond Town Center.
If you've not been to that one, it's basically, you know, right off the end of 520. It's pretty easy to get to.
Right, absolutely. All right. So tonight, our special event is a language panel presentation. We will be talking about 7 different languages tonight. And there's a template basically that we'll be working through to sort of compare and contrast different languages. And we're going to try to keep everybody to a 10-minute presentation. I'll be running a timer. And then what we'll do is after that, we'll open it up for Q&A. And we'll do our best to answer whatever questions you guys may have. Anything anyone would like to add? Anything you'd like to add, Donna?
No. Good summary.
Okay, thank you. All right, so we're going to run through some brief introductions to each of us. So you're up, Donna. Would you like to introduce yourself briefly?
Oh, sure. I thought that there was going to be I wasn't prepared for that, Brad, and the rest of you. But I'm Donna, and I have been an active programmer, both in embedded and for traditional PC desktops for a very long time. And I'm trained in electrical engineering and computer science both. And I have about 15 or so years of corporate engineering experience at notable companies such as Intel and Physio Control or Medtronic. And I now run my own technology services company called Your Tech and More. And as far as programming and robotics and embedded systems, I do that on the side for hobbies. And I know Lloyd Moore very, very well. He and I are co-conspirators, so to speak, in the Seattle Robotics Society group. And we both love robotics and all that. So that's kind of a brief introduction to myself.
All right, thank you. All right, next up we have Ted.
I'm a big geek. The end.
Walter.
Oh, yeah, I'm Walter Bright. I started my career working at Boeing on the 757 gearbox, and it's the actual gearbox that had nothing to do with software, since I'm a mechanical engineer and spent 3 years working on that and know an awful lot about the 757 stabilizer trim system and not much about a whole lot else. And then I switched to writing software, and I first implemented a C compiler, which was sold in the 80s. And then I was looking around for something more challenging and found C++ and implemented a C++ compiler and finished that. And then, you know, I had a lot of dissatisfaction with C and C++, and I knew what was wrong with it. And so I decided to create another language called D, which is incorporates all the stuff I've learned from that. And so I started D in around the year 2000, and it inadvertently became popular. And we have a whole staff of volunteers working on it to constantly improve it, like Bruce over there, who's our resident expert on multi-threaded programming in D. And D's become very popular, and the people who do use it very much like the language, and I'll explain why a little later when we get it more into talking about what D is.
Oh, thank you. And last but certainly not least, we have Dread Pirate Williams.
Arr, I am the dread pirate Williamson, scourge of the seas. Not the C++, just the seas. As a pirate, I know a lot about Navy things. I know a lot about evading the cannons, but that's not what we're going to talk about tonight. If I were not a pirate, if I were but a regular programmer, then I might have worked at companies such as Microsoft, companies such as Amazon, companies such as Google, companies such as Boeing. And maybe I would have some expertise from those companies to share. But alas, I'm just a pirate. Arg.
Where's your gold?
We had no idea.
Never tells.
And so you're going to be talking about R tonight, right?
Very swift.
We should have.
How did you not see that one coming, people? Come on.
We had no idea. Just wanting to say that right now. All right, Lloyd.
Okay, and I've got to follow this. Okay, I'm Lloyd Moore. Formal background is in biological-based AI. I've been a consultant for about 30 years. Embedded, lots of embedded stuff, lots of industrial automation. I was in aerospace for a while. I also am the president of the Northwest C++ users group. I've been doing that for something like 15 years. I also work with Donna on the Robothon, which is a robotics competition group, and Seattle Robotics Society. So I've been kind of all over the place. And now I'm here, following this.
Great. And yeah, and my name is Brad. You'll find me as U007D on online technical forums. I have been, I guess I'll date myself. I had a birthday last month. I started programming when I was 12 on a Commodore 64, starting out with BASIC and 6502 assembly language. And that actually set me up for a systems level programming career. Moved on from there to Amigas, C, C++ for the majority of my career, and then switched to Rust about 2015. I first started programming, I did the math, I couldn't believe it, I had to do it twice, 45 years ago. So, but actually Rust has helped me, has caused me to enjoy programming again. I haven't actually enjoyed it as much as I do now in decades. So I love it. My kitchen table is covered with projects, and much to my wife's annoyance. And I've worked through other languages in school. You know, back when the dinosaurs were roaming around, they taught me Fortran and COBOL and languages that I don't use anymore. Use Delphi, but basically a career in compiled languages, and only briefly touched, you know, things like C#. Java and JavaScript. Okay, well, I think that's pretty good for everyone, and let's go. I think Donna, you're up first. You can just tell me when to advance the slides, and we can go through your CPP2 slides.
Okay, so please advance to the first slide. CPP2 is best seen as an experimental syntax layer on top of existing C++. It's designed to be safer and cleaner code generated without replacing existing compilers and libraries that are out there. Its main goal, its main purpose is to shape future C++ versions and the overall frame of C++ rather than for immediate production rollout. It's attractive for its pragmatism and compile time improvements, but it's very, very early alpha, use at your own risk kind of stage. Next slide, please. So on to some language history, origins of it and who. It was conceived by Herb Sutter, led by CPP Front Team. What and why? It's a new syntax skin that's layered on top of C++ to eliminate about 95% of unsafe C++ practices while preserving full interoperability. When and where? It was developed largely by Microsoft engineers. It was first showcased at CPPCon 2022. It has an active GitHub project ever since then. Status, purely experimental, as I said earlier, though increasingly alpha ready. It transpiles to CPP 20, but is not yet production endorsed. Standardization body. No formal standards body yet. It is envisioned as an R&D incubator that may inform future ISO C++ features. Update schedule. It has a rapid iteration cycle with frequent versions. Next slide, please. Hey, here's a sample of code generated. It dynamically allocates an integer variable, spawns 100 threads, and each thread increments the variable 10,000 times. It uses std mutex to guard access to the variable and prevent race conditions. Now this compiles to standard C++ via CPP front. This code assumes use of CPP2 to C++ translation. Next slide, please. Memory safety features. Memory and lifetime management. It retains the C++ model, adds safer defaults via cleaner initialization patterns and tools for safe union and memory state. Automatic bounds checking. It's not provided by default. Focus is on safe idioms rather than runtime checks. Safe arithmetic and overflow. No built-in safeguards. The C++ standard behavior is maintained. Excuse me. Pointers and references. Fully supported. Encourages safer use via labeling, such as in-out, this, and const, but raw pointers remain. Forced initialization. Yes. It's inferred from Herb's bug stats, defaults, behavior, defaults favor initialized variables, avoiding UB-prone practices. Pointer arithmetic, it is allowed, unchecked, the same as C++. Managed ownership, no borrow checker, ownership is still manual. No automated memory management akin to Rust or GC. Next slide, please. Thread safe features. Sync primitives. Supports C++ atomics, locks, barriers via transpiled code, but no specialized CPP2 thread primitives. Reentrant safety. Inherited from C++ standard libraries, language does not enforce non-reentrant constraints. Thread local storage, fully compatible with C++ thread local. Immutable objects, use of const, not immutable by default. Immutable by default? No. Must explicitly mark variables as const. Communication primitives, follows C++ arsenal, message queues and pipes, but nothing specialized in the language tooling itself. Next slide, please. Performance. Translation. Transpiled to C++ 20 source and then compiled by standard compilers. No just-in-time or reinterpretation. Determinism. Yes, standard C++ determinism applies. Bare metal support. If your C++ tool chain supports it, so does CPP2. Optimization boosts. Faster compile times noted, avoids heavy template metaprogramming in favor of simpler constructs, improving performance and compile time tasks. Next slide, please. Development ecosystem. The tool chains. Uses existing C++ build tools such as CLang, GCC, MSVC, with the CPP front transpiler. Language support, extensive. It's 100% compatible with existing C++ libraries. Package managers, same as C++. IDE and editor, works via existing C++ parsers once transpiled. IDE support is indirect for now. Language server, no dedicated LSP yet. Relies on standard C++ tooling after transpilation. Community, it's small but growing. 29 plus contributors. active discussions on GitHub and Reddit. Last slide, please. Other considerations. Learning curve. It's moderate. There's a new syntax and postfix operators and UFCS. But conceptual overlap with C++ makes the adoption of this language very, very simple. Hiring difficulty, likely low. Engineers that are able and capable in C++ should be able to quickly pick up CPP2's syntactic sugar. Regulated environments. Safe subset improves compliance. However, no formal safety certifications yet. Embedded use. It's feasible wherever C++ is supported. No built-in resource monitoring features. The job market. Junior level, it's scarce. It's a niche technology. For mid and senior level people, it's scarce, though experimentation roles may encourage early adopters. Some special features of note. Unified function call syntax, or UFCS. Also, postfix rich operators for clearer expression, and a focus on clarity, safety, and tool interoperability. And that's a wrap.
All right, thank you, Donna. So one thing I would like to mention here is the template that you just saw us, Donna, run through. The program, we wanted to present the same non-trivial program in all of these different languages, but we had a challenge, like what is the non-trivial program? So what we thought we would do is we would actually show how you would deal with a concurrent operation, like if you're building a concurrent hash map or something like that, if you're building a fundamental part of a distributed system. There's a lot of complexity involved with that. And in our case, in our simplified example, we're simply incrementing a variable. But this is designed to model sort of a more complex distributed parallel processing, or at least a concurrent processing problem. So that's a little bit of the context there. All right, next we have Dread Pirate Williamson. Do you want to drive?
As you wish. So a Swift intro. So the language history. Swift was originally designed by Chris Latner at Apple. Swift is a programming language, as I said, designed at Apple, but it is now open source. So you can see swift.org to find out more about it. It was created first in about 2010. The first tool chain shipped in 2014, so that makes it about 11 years oldish now. Why? Because they wanted a modern programming language to replace Objective-C with some modern language features. So a lot of Apple, iOS, and Macintosh programming had been done in Objective-C, which is sort of like a melding of C and Smalltalk, but has sort of a lot of cruft left over from its early design stages. So they want to take advantage of a lot of the modern features from other languages, probably even a few things borrowed from Rust, to build a better language for programming in. How? It first shipped as a dedicated ground-up tool chain built into Xcode, but now you can get other things to use it, such as the Clang suite of compilers. And it's now an open source project with heavy contributions by Apple. So here's some Swift sample code. Things to notice here is we don't have mutexes. Instead, we have actors. An actor sort of has a mutex built into it. So anything on an actor will have the inside protected against everything else. And instead of just launching tasks with threads, we create task objects. So what we'll do is we'll create a whole bunch of task objects, which the operating system and the underlying libraries will decide when to schedule each task on an individual thread. And then in each task, we'll call the counter increment function on the actor, and that will basically solve the problem for us. So it's kind of elegant. It's a little bit less code. There's some things being done behind the scenes for you, like the scheduling of the individual threads, and the mutex is being incorporated by the counter itself, or by the actor itself. Memory safety features. So it uses automated reference counting. So in some senses, you get the best of both worlds of deterministic compile time deallocation and not having to have, or being able to have managed memory and not having to automatically delete everything yourself. On the other hand, it comes with some of the drawbacks of reference counting systems, which is you have to watch out for reference cycles. The system is not able to detect circular references and may not delete things. So one of the key things that Swift wanted to do is they wanted to make it a little harder to make errors. So for instance, when you're declaring variables, you've got two ways to declare them. You've got let and var. Let will give you a constant and var will give you a mutable variable. So sort of like Rust and several other languages, you have to declare whether you want something to be constant or immutable right up front. They're strong typing, but it's deduced whenever possible, which is almost always. They've got a built-in optional syntax with the question mark operator, which I'm not going to go into, but is built into the language instead of like C++. We have an optional of something. Let's see, let foo equal optional foo is how you can access something optional. The if let will only succeed if there's actually something in there. Otherwise, the block after it won't be executed. The idea is to prevent data races at compile time, but not all potential logical race conditions. So while they can analyze compile time for data races and throw you compile errors, prevent you from doing them, there are still other things you have to watch out for. All variables must be initialized. It checks automatically for overflow and out-of-bounds array access. All classes are reference types, so there's no pointers, and it's always clear whenever you're passing a struct or a class that you're passing it by val, or when you're passing it by value and when you're passing it by reference. The answer is almost always by reference with the class. So thread safety features. There's an async keyword in the code which alerts the programmer to everything on the line following is going to run asynchronously and will return sometime later. You have an await keyword to wait for the thing that you have run asynchronously to finish. You have a try keyword, which just, again, serves to communicate to the programmer the operation on the rest of this line might throw. You don't have to write a catch like you do in C++ every time you write a try. You can only write the catch when you want to. You just write the try to say, this thing might throw. We talked about tasks and actors, and we talked about how it detects and prevents races at compile time. So performance, it's compiled. It can be very fast. I'm not sure if it's as fast as languages who've had more time for the compilers to optimize how the language is built, because this is one of the newer languages, but I think it's up there within a factor of like 1.5-ish would be my guess. Exceptions, they have exceptions that are just as efficient as regular code. You don't have to do stack unwinding like you did in older versions of C++. I think maybe newer versions of C++, the exceptions are getting to be fast as regular code, but for older versions, that was a problem. Development ecosystem, there are several tool chains available. There's Xcode if you're developing on a Macintosh, and Clang has a compiler for it. Available platforms, iOS and Mac, which is exactly what you'd expect, but also Linux and Windows. So sort of like C# has Mono, Swift has compilers that will work on Windows and on Linux. In fact, they even have ways to call the Windows SDK when you're writing programs in Swift. So yes, it actually can be used on Windows if you decide that's something you want to do, or if you decide that's your cross-platform strategy. Swift UI is a new way to build a user interface on the Mac and the iOS. If you've written iOS apps before, you have basically an interface builder. You drag and drop some things. Sometimes it works, sometimes it doesn't, whereas Swift UI has worked fairly reliably for me. They've got a package manager, Swift Package Manager. They've got IDE and editor support. I was able to find support for Xcode, obviously, VS Code, Emacs, Vim, and Sublime, but there's a list of other editors that have some partial support, if not full support. The community size is medium. So it's been in use in production Mac for some time now, and there have been a lot of people who have lately been building all the new iOS apps and all the new Macintosh apps in Swift. Other considerations, as I mentioned before, it tries to make errors hard to make. The code tends to be very clean. It takes advantage of a lot of the lessons learned in other languages. So when you read some Swift code, it might be clean and fairly easy for you to read, even if you've never read Swift, even if you're just like a C++ or C programmer. As I mentioned before, nice syntax for optional values. It has interoperability with Objective-C and Objective-C++ if you need it. And it can natively even use C++ libraries and call out to them directly. Job availability is mostly for companies who are writing things for the Macintosh or iOS. And that is everything. I will turn it over to the next presenter.
Thank you. Hi, Rich. All right. Next, we have Ted for C#.
Okay. Start a time for 10. All right. So let's talk about C#. This is definitely one of the more mainstream languages. One of the things about C# is, like its forebear Java, C# will compile C# source into a bytecode, which is formerly known as Common Intermediate Language, CIL. That bytecode is then, when the program is executed, it's then just in time converted over to native code. Unlike the JVM, C# will always just in time compile this to native. On the first invocation, it immediately triggers that translation. So technically, we can say that C# is always being compiled into native code throughout the entirety of the program, even when it might actually make less sense to just leave it in an interpreted mode. One of the things when they first developed the .NET platform, they actually said in the beginning that, yeah, CIL is not intended for interpreted. It's purely intended as a compiled bytecode. And then Miguel went and did Mono, which was actually interpreting it to start. It's object-oriented, strongly typed in the same way that C++ and Java are. There are people who will turn up their noses at the strong typing of C# and Java and C++. There are other people who will say it's not strongly typed enough, but it fits in that mainstream spot. It does support operator overloading. This was one of several decisions that Anders Hallsberg made into C# away from Java. It's definitely a language that's intended to be attractive to the C++ developers as well as to the Java developers, kind of charting this middle path between those two languages. Implementation and interface inheritance. It also supports parameterized types, generics, and in many respects, it was actually part of the push for Java to be able to support generics. There was a period of time in the 2003 to 2008 timeframe where the two languages were very much sort of lined up against each other. Are you going to get this feature first, or are you going to get this feature? They kind of squabbled with each other a little bit. In the very first release of C#, you could actually take a Java file, rename it .java to .cs, and depending upon which libraries you called, you would do like a simple search and replace. Like Hello World required one search and replace, and it would compile. They were that close to one another. They have since deviated significantly. The runtime environment, the CLR, it works with assemblies. When you create a program in C#, whether you create an executable, that is to say something with a main in it, or whether you create a library, that is to say something without a main in it, either way, it's an assembly. This is still a PE file format. It still is understood as an executable by the underlying operating system. The difference is literally 1 bit in the header indicating whether or not it's directly executable or not. But the assembly is something that is well known, understood by the runtime. And when I look to create dependencies, it actually tracks not only the name of the assembly, but also a version number and potentially, if that assembly was signed, a hash of that assembly. This was intended to provide a way to put more manifest style checking against the programs that are executing at runtime. In the early days, Microsoft actually envisioned a giant pool where all of these assemblies would live side by side and be versioned. That turned out to be less attractive than we thought it was, and they've since deprecated a lot of that functionality. It's fully multi-threaded. We have the ability to kick off threads, just like C++ and some of the other languages do. Automatic memory management, it's fully garbage collected. They do have, through their foreign function interface, what they call pinvoke, the ability to work with unmanaged pointers. So if you sit down and read a lot of the .NET literature, you'll hear managed versus unmanaged. Managed code is basically the C# code. Unmanaged code is something written in native that C# can call into. It knows how to line the stack up appropriately in order to be able to call into anything that exports a C-style interface. It also understands the difference between managed and unmanaged pointers. So it can understand managed pointers are things that are owned by the garbage collector and it can move around. Unmanaged pointers, yeah, I'm not going to touch that. We just leave it as is. Interop was a very big deal for Microsoft for fairly obvious reasons. They wanted to be able to leverage all of their unmanaged code from within their new platform. So this is an example, sorry, it's a little small, of using raw threads. So here, basically, we just have a class. It's got a, what I call it, go instead of main. We have a counter type, 100 threads. doing 1,000 increments. I think I misread the number of zeros, sorry. Okay. But fundamentally, this is just basically kicking off a thread, and we're doing some of the, we're doing in this case, this is completely like, we're just running side by side. Interestingly enough, because the underlying CLR guarantees atomic access for 32-bit values, the increment and decrement operations are implicitly thread safe. One of the things that both the JVM and the CLR established was the idea that if you're doing these word size operations, this is part of the memory model, we guarantee that those will be atomic operations. So in some cases, we don't even have to bother with locks. Now, the danger of that is you could very quickly get yourself into trouble in terms of how you're doing some of this. Whoops, I didn't want to do that. I wanted to go down. They also introduced some higher level features. In this particular case, I forget what TAP stands for. I think it's Thread Access Protocol Parallel Libraries. They had the TPL, the Task Parallelization Library, which was intended to allow for a variety of different multi-threading scenarios to be addressed. In this particular case, they added a parallel class that supports the notion of a parallel 4. So here, what I'm doing is I'm specifying basically the number of parallel loops I want to do from 0 to threads, and then I'm passing in a delegate, which will be executed simultaneously. The CLR maintains a thread pool, a collection of threads available to it to use for a variety of different operations, including asynchronous delegate invocation. This was introduced in C# 2.0. And so I'm just making use of that implicitly under the hood here to do those operations. Going back to the template here for a second, Anders invented the language, actually stole him from Delphi. It was all the rage at the time. It was very sad, very happy if you were a Microsoft fan. Anders brought with him a lot of that Delphi experience when he sat down to redesign the new language, with a very keen eye towards how do we preserve a lot of the C++, C-style legacy, let's make sure it's attractive to Java developers because this is the pool that we're trying to go after. Obviously, Microsoft did it. The first public work was announced in October of 2000 at the Microsoft PDC down in Los Angeles. They'd actually been working on it for several years prior. I happened to be teaching for Developmentor at the time, so we got kind of a sneak peek several months ahead of that. And the story goes that the CLR team knew that this was going to be successful if they could get two groups on board, one being the ASP team, in order to be able to migrate ASP over to ASP.NET, because nothing says web server stability like getting a null pointer in your C++ plugin running inside of Internet Information Server. The other was Don Box, who, if you're not familiar with the name, he was a he was the lead instructor. He was the founder of Developmentor, very, very influential within the Microsoft community. Initially, oh, sorry, go ahead. 2 minutes, holy crap. So much stuff to go over. Initially, they did it very bluntly because Sun sued them. They originally wanted to actually embrace the JVM and actually build some extensions on top of it because they really liked the idea of managed code. But if you remember back during the late 90s, Sun got upset when they made those extensions and said, you can't do that. Microsoft said, yes, we can. Sun said, no, you really can't. And then the DOJ got involved and said, you are a monopoly. And okay, Microsoft said, all right, fine, screw it. You can keep your language. And applets basically died that day because the next time you bring up Internet Explorer, there was a big gray box where the applet was supposed to be. And yeah, anyway, it initially was closed source, but very quickly they open sourced it. There was an open source release called Rotor. That was released in 2001. It was basically the core CLR code minus pinvoke and the com interop functionality of it. That has served as the seed for what is now completely open sourced. Mono, by the way, has gone away. Mono no longer exists. The Xamarin team was brought in by Microsoft. And then shortly thereafter, Microsoft, the .NET SDK was fully open sourced, and now you can be on your Mac, brew, install .NET, and lo and behold, you can run C#. And again, it's still just-in-time compiled. It's running native instructions. Garbage collected, auto bounds checking, safe. Well, I mean, it does the same sorts of things that C++ and Java does. It'll overflow if you put too big numbers on it. It won't blow up the program, but it's still safe. I mentioned managed references and pointers. Yes, I'm done. And forced initialization, everything is automatically initialized to 0 or null, whatever's appropriate for that particular type. We have a number of Windows primitives for synchronization. They also borrowed from Java the notion of object monitors. Each object has an associated monitor. If you use the lock keyword, we do an atomic reach for that monitor. We can use that as a very primitive way to control execution. Thread local storage, immutable objects, we can sort of build them. It's really no better than C++ or Java or any of the other languages. It is not immutable by default, although if we're on the .NET platform, we do have to acknowledge the fact that there are other languages for the .NET platform, such as F#, which is an object functional hybrid language, which does support immutables by default. So if you really want that, maybe you want .NET, but you don't want C#. Translation, I mentioned it's compiled to bytecode and then JIT compiled. Deterministic, we do lose something. We have a virtual machine there, and it is doing garbage collection. It is, in fact, looking for ways to try to be more deterministic, but at the end of the day, garbage collection occurs when the machine decides, hey, it's a good time to be able to do garbage collection. One of the things that both Microsoft and Sun, later Oracle, have experimented with is different algorithms for garbage collection, when to kick it off, etc. Available tool chains, Visual Studio, VS Code, and I mentioned the .NET command line tool. The library support is extensive. There is a package manager called NuGet. There's a lot of IDE editor support as well as lang server ability, and the community is huge, absolutely huge. It's one of the mainstream languages out there, which also means that if you're looking for a job, chances are very strong that you can find it doing C#. Ironically, not necessarily here in the Seattle area, but particularly if you go out into the Midwest, a lot of companies out there have very aggressively embraced the .NET stack. FinTech, your Java, but a lot of other stuff is really very, very friendly to the .NET stack. The special feature of C# and .NET to piss off Linux developers. And this is me. Meanwhile, I'm also doing Mojo, right? I'm next? All right. All right. Now, we go from one of the most well-defined languages on this panel to one of the least well-defined languages on this panel. Mojo is extraordinarily experimental right now. Right? Even CPP2 is more solid in terms of some of its definition than Mojo is. An innovative, high-performance programming language designed for writing systems-level code for AI workloads. Okay? Keep in mind that Mojo really, really, really wants you to associate it with AI. Really wants, even though technically it's really not all that. I mean, it's not like it's got an LLM embedded inside of it or anything. The examples you see on the Mojo website show you doing pretty much the same thing that every other programming language does, which is, hey, let me call that LLM over there and get you results. It is intended as a language for embarrassingly parallel kinds of problems. C# is not. C# is designed for really those scenarios where you need to do lightweight threading. But like, for example, if I were to show you a really compelling Hello World in Mojo, I would show you Conway's Game of Life. If I were to show you a compelling example in C# threading, I would show you, hey, let me keep the message pump running so that your application remains responsive while asynchronously you do a fetch from a HTTP URL. They are really designed for two very different kinds of problems. Now, the other thing about Mojo that I have to say right up front is, even in the 3 months between when I started to write these slides and now, Mojo has changed. Okay, so there's not a lot of detail in the slide deck here, mostly because I don't want any of you coming back to me in 3 months and saying, hey, I looked at your slide deck and it says it uses this keyword, but when I tried to compile your sample, it doesn't work. Yeah, welcome to Mojo. Okay, if you need help, then clearly your Mojo has lost its mojo. Come on, guys. That's the best joke I could come up with for this language. Give me something. Anyway, Pythonic syntax. Chris Latner, same guy who did Swift, actually got hired away from Apple in order to start working on Mojo. Both languages make use of the LLVM toolchain. This is a compiler backend toolchain. And part of the reason for that, there's a lot of languages that use LLVM. Part of the reason is it does actually have some really strong optimization behavior to it. So there's a lot of oomph we get just by using LLVM as our backend. The goal, though, was to be very Pythonic. Why did I mention this language likes AI? And what is the mainstream AI programming language? Nobody say JavaScript. You need to leave, sir. Perl, no, get out. Take your Dr. Pepper and get the hell out. Python. Everybody loves Python in the AI community, right? Well, they wanted to make use of that syntax, again, because as a language designer, you really want your syntax to be attractive to your target audience. And if you're going after the AI community, Python. That said, they introduced strong typing. So now it's Python with type hints, except these type hints are required, not optional like it is in current versions of Python. It is compiled. It does have an ownership memory model. And it does do some compile time parameterization. I will not go so far as to say they have generics or templates the way we think of them in C++ or C#, but they do have a fair amount of compile time meta-programming capabilities. The other thing that Mojo really stands out for, that last bullet, GPU integration. When Mojo does Conway's Game of Life, it wants to feed all of that work onto the GPU. That is to say, onto the 10,000 GPUs that you have inside of your modern desktop rig. That's really where a lot of its benefit is going to come from. So, let's see. Chris Latner works at Modular. That's the name of the company. That's also the name of the platform. Modular.com/Mojo. First available in September of 23. They announced it in May. So they obviously were very eager to try to get things out in front of people. There's no document anywhere that indicates how long Latner might have been working on or feeding ideas about this prior to May 23. Why? AI, duh. We need to have a language that somehow does AI. Initially, it was closed source. They've been, most recently, they've started putting stuff up onto GitHub. A lot of that started as samples and documents. Now they're starting to put more source available. I don't know if you can build Mojo from source yet. I haven't tried. But they know that they want to be open source. They've just, while they're trying to settle a lot of the core things down, they did so in-house. Status, they will happily sell you a license. But God help you if you try to put this into production, because did I mention that stuff has changed? Keywords have changed. They used to support the idea, for example, of using let as a keyword to introduce a constant variable. They've since backed away from that, and they're just going with a unified var now. So there's a lot of stuff that's still very, very up in the air. Auto bounds checking, safe arithmetic, pointers and references, they have explicit types. There is a pointer type. And the pointer is actually compile time parameterized as to whether it's a pointer to an int, meaning it's 64 bits, or it's pointer to a byte, which means it's 8 bits. So they've got support for that unmanaged stuff, particularly because in a lot of this world, you really do want to have direct access to the metal to be able to do this. They don't force you to initialize local variables, but if you try to use an uninitialized local variable, they will fail to compile your program. So it's kind of forced, but kind of not. They do have a number of synchronization primitives, but a lot of this other stuff, they've really, either they don't have it, period, or, because they want to push you out onto the GPU, right? If you're thinking about locks, you're probably not thinking about your problem correctly. We really want you to be thinking about how would you get 10,000 cores to all be running simultaneously, and if they're all having to take a lock, you've probably already lost. So they're really pushing away from that. Now, in an earlier version of Mojo, they didn't have, for example, any sort of atomic behavior. They've added that to the standard library since. The immutability by default, I think they started down that path, but they seem to be backing away from it. Now they seem to be saying var, meaning it's mutable unless you explicitly declare it as immutable. It is compiled It is deterministic because it's a compiled to native code language. When you run through the tool and you build something, you get a native ELF or portable executable file if we do this on Windows. That said, they don't support Windows yet. They must have a Linux toolchain. So if you want to experiment with Mojo and you're on a Windows machine, WSL is your friend, which truthfully, WSL is your friend even if you don't want to experiment with Mojo. It's a great way to do stuff. And like I mentioned, it's all backed by LLVM. They do promote explicit access to MLIR. This is a toolkit that works with LLVM to provide some higher level access rather than LLVM primitives. This is kind of your trap door if you really want to fall through and do some execution directly. The available toolchain. This is a funny story. When I started working on these, they had a tool that was called Magic, which was a command line tool. You would go into your project directory and say magic init, and then you would say magic run mojo hello.mojo. Oh, and by the way, the extension is either Mojo or literally the .fire emoji. I'm not making this shit up. I'm really not. Okay. That said, as I was going through my samples, I have some demos, by the way, up in GitHub. It's literally tedneward/demo-mojo if you want to go look at all of this stuff. They changed their build tool. It is no longer Magic. It's Pixie. Well, according to the website, originally they were going to use Pixie, but Pixie didn't have some functionality that they needed, so they forked Pixie in order to get that functionality. But now that Pixie has that functionality, they've ripped out Magic and gone back to Pixie. Okay, I get it. We'd like to get this right. You need this functionality, etc. But seriously, I mean, couldn't you have at least warned us ahead of time that Magic might go away in the future or something? So this is what I mean by there's all this stuff in Flex. They support the notion of creation of libraries, but in terms of a package manager, presumably it's going to be Pixie based in some way. And because there's a tremendous amount of influence and integration with the Python community, we kind of have to throw Python under this umbrella too. They currently use Conda, which is one of the Python package management schemes, as a way to distribute stuff. As a matter of fact, when you Pixie init, you actually have to make sure that the Conda nightly channel is available inside of the Pixie manifest. Yeah, this is why they've got a ways to go to really smooth this out. It's very clearly not ready for production. And the community, there's like maybe 5 people in the world who are not core committers that are talking about Mojo. All right. Let me speed this up here. Is it easy to learn? Well, I mean, they've got pretty good documentation, but when everything is in flux like this, whatever you learn today may not be there tomorrow. So, you do the math on that one. Find developers, very, very hard. Although in the future, Python developers should be able to move over to Mojo without too much difficulty. Should, with a really big asterisk attached to that. Suitable for use in regulated environments, embedded environments? Not right now, it's not. I'm not sure it ever will be. Again, this is for embarrassingly parallel kinds of problems. Job availability, special features, easy GPU integration is really the big special feature I would kick off there. Again, that's me. And Walter, you're up.
Hello, and I guess I already gave an introduction, so we'll just jump right in. D started as I just wanted to have do a new language with a primary goal around that the languages that I was using before were frankly ugly languages. If you want an example, just take a look at the /include directory of your favorite C compiler and look at the .h files in there. They are all incomprehensible, and yet they're written by experts. And so I don't think there's anything wrong with the experts. I think there's something wrong with the language that somehow it encourages the writing of incomprehensible code. So I wanted to create a language that is beautiful to look at, easy to understand, and is plastic. And what I mean by plastic is I discovered with my C code that once I picked the initial data structure and algorithm, it never changed through the life of the program. How many have that experience? Okay, that's a language that's brittle. A plastic language will enable you to quickly try various algorithms and data structures without major disruption of your code. And so you can create evolve a much better program over time than you can with C. Every C program, and C++ ones I've seen too, get stuck in the past of their original design decisions. D is completely open source. It's all Boost license, which means there are no onerous restrictions on it. We don't care what you use it for. Use it for whatever you want. Have fun with it. It originally started out as C with classes, the implementation. And then once we had a bootstrap ready thing, the entire compiler was converted over to D, of course, doing the dog fooding. The D Language Foundation is a nonprofit, and I have never accepted any compensation for it. It's run by volunteers, and which is really great because the people we have working on it, they're not doing it because they're paid to, they're doing it because they love it. And that says a lot. That's the highest compliment you can get for a language is people want to work on it with no compensation because they love it. We have mature production compilers using DMD, which is the backend I wrote eons ago that I keep moving forward. And DMD's main feature is it compiles really, really fast. The other two versions of it is one is based on the GNU compiler collection, and the other is based on the LLVM backend, and which means that D code is as performant as C and C++ is because similar constructs compiles the same code. It has a standards body, which is the D Language Foundation. And so much for that. Okay. I received the challenge for writing a piece of multi-threaded code, and I didn't know how to do it. So I typed it into one of those AI things, and it came up with this. It looked like perfectly reasonable code to me. So I sent it to my colleague Bruce over there to fix it. And and he came up with this. And I know it was said earlier that this was a non-trivial program was supposed to be the result of this exercise. And I think if you look at it, doesn't it look like a trivial program? I mean, mostly it's just a bunch of imports. And the actual code is trivial, and it's really hard to beat that. And that is thanks to Bruce, who is an expert on parallel programming, who wrote this for me. So I really appreciate that. Saved my bacon there, because you just look at it, you know what it does. And that's one of the nice things about it. You don't need to know D to know what this program does. It's got a collection of memory safety features, and the usual ones: safe code, optional garbage collection, scope pointers, all that stuff. But it divides your code into safe and unsafe code. In unsafe code, you can do whatever you please. In safe code, there are a bunch of restrictions, mainly for memory safety purposes. And so the idea is to minimize the amount of unsafe code in your program and maximize the amount of safe code. Thread safety features, it's got all the usual thread safety features. A couple interesting things about it is thread local storage is by default because that's thread safe. Global memory tends to not be very thread safe, so global memory or global static memory you have winds up being an unsafe code, not safe code. Mutable objects, D has, unlike C and C++, immutability is transitive. Everybody knows what transitive is? Okay, const only works at one level in C and C++, which means you can declare something as const, but it only protects the beginning of the data structure, not the elements of it. And that's not terribly useful. But it turns out that with transitive const and transitive immutability, all of a sudden you have thread safety guarantees. Because in immutable data, you don't need any thread locking to read it. You just go ahead and read it because it's immutable. And it also enables the ability to have pure functions. So people complain that pure functions in D are very rigid. They're not going to let you get away with anything in a pure function that isn't pure. And the neat thing about it is when you finally get your code to be pure, you know it's thread safe. And you're going to have a lot fewer bugs with it. So one of the things I like to do when I'm refactoring code is I try to refactor it so I can maximize the number of pure functions and minimize the number of functions that modify global state. And this is a fun thing to try to do with your programs, to divide them up like that. It's not the usual way people do things. Usually the way people do things is they'll have the top level code, which goes calls, and down at the bottom, it's got a printf statement in it. Okay, this is not, you can't have a printf statement in pure code. And so the idea is to find a way to kind of reverse the hierarchy so that the printf is at the top and then your engine is all the pure code. So D has a number of features that are designed to make that practical. And once you get used to it, I guarantee you're really going to like programming in that style. It makes your code easier to understand. Pure functions are much easier to debug, much harder to make a mistake with, as the compiler keeps going, your function's not pure. Of course, you get C and C++ performance because it uses the same code generator, and it doesn't add extra junk in there to make it slower. There's a careful balance of features to make sure that you can get top shelf performance out of it. And the optimizers in the GCC and the LLVM are really, really, really good. And there's no point in fighting that. So we joined it. And so you have no problems with that. It also lets you do bare metal. It even has an inline assembler. How many of you are using languages with an inline assembler? Oh, more than I thought. Are those part of the language or an extension? Part of the language. Cool. All right. And yeah, I'm not going to read the feature list for you. Development ecosystem. We already talked about the tool chains. One interesting thing is we've had some issues with interfacing with C code because people really want to use D, and they got this mass of C code and they can't talk to it. And people would spend hours and hours and hours hand translating C.h files into D code. And then there'd be an update to the .h files, and then they go, So this was a large barrier for us. And my first thought was, why don't I just write a C compiler and fix that? And then I thought, oh, that's a stupid idea. That would take far too much time. And it kept coming back and coming back and coming back. And since I'd written a C compiler before, I thought, well, maybe I can adapt my old C compiler to do this. And the problem was I wrote that C compiler in the 1980s, and it's written in such a horrible, primitive style. I just decided there was just no hope for it. 2 minutes. Okay. So what I did was I scrapped the idea and decided that all I needed to write was a C parser. And so I wrote a C parser, and now it can read and parse your C code, and internally it gets translated into D code. And people were initially very resistant to this idea. Why are you wasting your time writing a C compiler? And they came back to me in a couple of months and they said, my God, my productivity has gone through the roof because now I can use all my C code. And your D code, their D programs can import and use it directly without any modification. Well, since one of the focus was easy to read. It's easy to read. People coming from Python say it's actually very Python-like, and it's ease of reading and working with. Industry experience with it is if you know C++ and you know C, you fit right into D. It's very, very similar, except it's nice to look at and it's easier to debug. Use in regulated environments, sure. Embedded environments, yes, we've got embedded users, job availability. We have companies coming to our D language conference specifically to hire D programmers because they find that people who program in D professionally are really, really good hires for them. So D looks really good on your resume. Special features. It has the best meta programming in existence. Other languages are still trying to catch up. D pioneered compile time function execution, D pioneered universal function call syntax, all of which make your code easier to read and easier to debug. And there are a number of other features of D that have seeped into other languages, which makes our D community really proud that people are adopting our stuff, and we welcome that they adopt it. You know, it's we're working on D to improve programming for everybody, and if you want to steal our features, feel free. Well, like we have an excellent module system in D, and C++ finally came out with a module system, and I started reading the specification and going, oh my God, why didn't you just copy what we did? What we did works, and it works great. It's been around for 20 years, and very, very few complaints about it. Nested functions. Why don't other languages have nested functions? They're a fantastic feature. Ranges were pioneered in D, and now everybody's using ranges. Forward referencing. Isn't it crazy in C and C++ that got the hook out?
Da, 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 da. Sorry, I don't know. I don't
Sorry,
know
guys,
what music they play at the Oscars, but
I guess I'm being thrown off the stage here. So anyhow, if you got questions for me, come up after the show and I'll do my best to answer them.
Oh man, that's tough. All right, Lloyd.
Okay, the mic is working. Good. Okay, I'm Lloyd Moore. We've already done my introduction. So I'm talking about C++. The language was created by Bajor and Strustrup. It was created to be C with classes, and that later became C++. The work was done at AT&T Bell Labs. It started in 1982. The first commercial implementation was released October 1985. Basically, they wanted to bring features from Simula and several other programming languages to C. It was initially implemented as the C-front compiler and later became dedicated compilers that we know today. Status, it's in full production, obviously. Multiple standardized implementations and extensive support. There's also several specialized compilers for certain things. The update schedule generally operates on a 3-year release cycle. One of the key aspects with C++ is they mandate full backward compatibility. So this is really good in some sense and a limitation in another sense. If you've written code, it's guaranteed to work going forward. That also limits what they can do in some cases. There is a standards body, and you can't really see it in the slide. It's isocpp.org. Okay, here's a sample code. Looks a lot like some of the C-frontish stuff. It's pretty straightforward. Oh. Okay, there's memory. I know, that's okay. That's okay. As long as the Dread Pirate Williamson does not kill me. Okay.
Well, I'll probably kill you in the morning tomorrow.
That figures, yeah. Okay. Anyway, memory and lifetime management. It's manual and or reference counted, depending. You can do both. Automatic bounds checking, no, but it does have collections, iterators, and ranges, which if used properly, basically give you bounds checking. Safe arithmetic, no. Pointers and references, they're supported but not safe. Forced initialization, not in all cases due to backward compatibility. Pointer arithmetic, yes. Managed ownership, none. You got to do that yourself. Sync primitives. You've got atomics, locks, and memory barriers. They're all fairly low level. Reentrant safety is manual. It's up to you. Thread local storage, yes. Immutable objects, yes. Immutable by default, no. Communication primitives, pretty much whatever you want via external libraries. Next slide. Translations compiled. I believe there are a couple interpreted variants out there as well, but for all intents and purposes, it's compiled. Deterministic at runtime is manual. If you code it properly, it's deterministic. If you code non-deterministic things, it's not going to be deterministic. Bare metal programming, yes. Other features, you can generally get, quote, hand-coded performance with moderate effort. The last thing I really wanted to say after all of this was you get performance equivalent to C and C++. There are intrinsics and assembly is supported. SIMD data types are coming in C++ 26. Okay, the development ecosystem. GCC, Clang, MSVC, Intel, NVCC, that's NVIDIA's compiler, and there's others. There's a lot of compilers out there. Some of them very dedicated to special uses, like NVCC is NVIDIA's compiler for the GPUs. Library support is extensive. Various package managers, Conan, VC package, CPM, Hunters, there's more. IDE and editor support is extensive. Visual Studio, VS Code, Eclipse, JetBrains, Vim, Sublime. I could spend another several minutes going on with that. Language server available, yes. And the community is large. I probably should have said very large. Other considerations. It's fairly easy to learn, although its deep history makes it harder. One thing I found with the language being as old as it is and having gone through as many iterations, there's multiple different coding styles present. So as I kind of mentioned, I do consulting work. When I go into different groups, many different groups have different coding styles that look like different languages. Some people tend to do everything with templates. Some people tend to do more functional stuff. Some people tend to do more procedural stuff. Some people do deep object-oriented stuff. You can do all of that, but it means when you come into it and learn, there's a broader base of stuff you need to learn to read the entire code base or the entire range of code you're going to come across. Developers are pretty easy to find. It is suitable in regulated environments, and many standards support this, typically with some language restrictions. So, I believe MISRA has I think MISRA has released their C++ standard. Does anybody know for sure on that? It's in process if it hasn't been released. Anyway, there are formal standards and to support regulated environments. It is suitable for use in embedded environments. It's very well supported. It's got a very deep history and natural interop with C. Matter of fact, if you want to write C code in a C++ compiler, it just works, right? There's nothing saying, and that's the way a lot of people transition from C to C++. And they sell it as just a better C. The ISO standards body prioritizes backwards compatibility. We kind of already talked about that. It's considered a safe option for most projects. So if you're in charge of picking a language for a project and C++ is reasonable and you say, we're going to do this in C++, you probably won't get too much, nobody's really going to challenge you on it. Some other languages, even though they might be more appropriate, you're going to get some pushback in some cases. Job availability, jobs are pretty ample out there. you're good at C++, you're pretty portable. And that's it for me.
Set my timer. Okay. So yeah, I'm here to talk about Rust. So Rust is compiled down to your native target instruction set architecture. It's non-garbage collected. It is multi-paradigm. So a lot of what you were just saying, Lloyd, about different code bases can look different. You can have people programming very imperatively with for loops. You can have people programming very functionally with iterators. You can have, have it look a little bit more like Haskell or F#. So you can support this within Rust. And I try to do a small example of that in the example code coming up. It's a systems programming language, which means you have control over everything. You have stack, you have heap, you have byte control. You can worry about alignment, padding, layout of structs, and you have C interop as well. And it's designed to operate in exactly the same spaces as both C and C++. If you don't know about Rust yet, it's sort of shaking things up a little bit because it is coming into these spaces which with memory safety as a feature. And people were thinking that, it would be hard to do that. But Rust is now in Android, which is predominantly a C++ code base. And Rust is also now present in the Linux operating system, so which is a C code base. And it's, controversies aside, it's doing its job in both domains. So I'll move through these really quickly. It was created by a language engineer, not a programmer, but a language engineer by the name of Graydon Hoare. It was created while he was working at Mozilla. He started developing this as a personal project, I think, back in 2006. And Rust 1.0 was released in just recently, actually. We had our 10-year anniversary, but in May 15th, 2015. So Rust is really designed to be safe, and it's designed to be fast, and it's designed to have a good onboarding experience. The Rust team, we actually have a Rust language team member here in our audience. They spend a lot of time trying to make the compiler give you what we call friendly error messages. And if you've ever done I think the poster child of unfriendly error messages would be template metaprogramming in C++. And so you get like one little thing wrong, and it's a screen full of inscrutable something or other. So the Rust compiler is known for hand-holding. Right? It almost reminds me a little bit of the Clippy from the old days, right? It looks like you're trying to do this, but it's well known and well respected for that. It does beat you up later, right? As you get into lifetimes and other things, it becomes a little bit difficult. That's famous, but we'll talk about that a little bit. It provides performance on par with C and C++, and it's noted for an excellent documentation. So Rust went through its Mojo phase. Rust went through its Mojo phase where it was pre 1.0 and people would get very upset that breaking changes got made. But in the end, once it stabilized, they took that very seriously. So this is like a big problem. Writing a multi-threaded code in C++ that works well is a big problem. Mozilla rewrote major sections of the Firefox web browser, which is a C++ project, multiple times to try to fix some issues with it, and didn't make material progress, right? This is not for lack of having smart people. It's just the complexity of the problem was too hard for the human brain to manage. And so this is where Rust came in and made a big difference. So Rust it stole liberally from other languages. In fact, Graydon was very proud of the fact that he stole ideas from old languages. He actually didn't want to use any ideas from languages newer than the year 2000. He thought there were tons of old languages out there that had great ideas that had never made it mainstream. So I went through and pulled a lot of them. Those are all links. So if you download this, slide deck and click any of those links, it'll cite what the language is and what aspect of Rust was inspired, right, by that feature of the language. So Rust releases every 6 weeks, a new point release every 6 weeks. I think we're on 1.88 right now. And it has something called an edition that comes out every 3 years. This famous backwards compatibility that C++ provides is both a boon and a curse. And so Rust has taken on an edition which provides both forward and backward compatibility for, I would say, very deep and extensive changes, but not any possible change in the language. But what it does is it provides a degree of freedom where the Rust itself, you can make breaking changes to the language, and you can have the new edition, we're on 2024 edition right now, can run in a certain way. The 2024 edition can compile right alongside 2021 edition, 2018, and 2015 edition modules. Doesn't matter, they just work. And the compiler knows what set of rules to use for each type of module. And every module, every chunk of code, every package that you download and compile with will identify what edition of the compiler it uses. And that provides a significant degree of freedom to make breaking changes when we get things wrong in the language. Oops, wrong way. All done, see ya. All right, Rust is there's a safety critical variant of Rust called Ferrocene that's available. It's used in automotive, it's used in industrial and medical. There are some aerospace qualifications in the pipeline that's working. Rust currently runs with LLVM as its backend, and so we and there's projects to get it working with GCC. There are some targets that GCC supports that LLVM doesn't. And so folks are looking to have Rust on those targets as well. There's not an ISO standards body, right? It's a difficult thing to sort of wrangle a lot of different competing needs. And so Rust has a different RFC style format with the language team, team leads, and a foundation, behind all of that, sort of powering all this. But it's an interesting model, and I think it's, it has its challenges as well, but I think it's working so far. So here's an example of the Rust code doing the same thing, sort of modeling a complex problem itself. And we're starting, I've highlighted the use and the static. So the use is just pulling in aspects of the standard library that we need to use. And we create this atomic unsigned 64-bit integer, and we initialize it to the value 0. And you can see down here, where we are doing this rather unusual, command. We say count.fetchAdd. Whenever you read, whenever you increment a variable, you're going to read it from memory, and the CPU is going to put it into a register, and then you're going to modify it in the register, and then you're going to write it back out to memory. So that's what's happening under the surface. And because an increment operation, as you and I might think of it, is really composed of those 3 distinct steps, unless something special is happening behind the scenes, your program could get interrupted before it completes all 3 of those steps. And technically, you want it to do none of those steps or all 3 of those steps. And so an atomic will ensure that through an instruction called fetchAdd. Rust also supports locks, mutexes, and I have an example of that, but I probably won't have time to go through it. And at the end of the day, we have to use a load instruction to get out the value from your atomic. And there, you'll notice there's a parameter here called ordering, which is, I'm not going to get into concurrency in terms of memory fences or anything like that today, but I would say that if you are using atomics, and you can just think about, just use ordering sequentially consistent everywhere. And while you will be leaving some performance on the table under certain circumstances, it will never be wrong, right, for what you're trying to do. And that's the safest way to get started. This is proudly stolen from C++, the atomics model. It's an exact duplicate, flaws and all, of the C++ model. And it's actually pretty good. And if you run this, the variable will increment all the way up to 1 million. There are a bunch of learning resources that I put here for anyone coming through this deck. Rust does manual-based memory management. It uses, Bjarne's world's best acronym, right? RAII. It uses RAII as a model. So whenever anything local to a scope goes past the closing curly brace, that that resource will be dropped, and that can be memory, that can be a file descriptor, that can be a lock that you have for resources. It's very well implemented. The complex part of Rust that most people wrestle with when they're getting up to speed is dealing with lifetimes. So if you ever see like an apostrophe and then a letter like a tick A, that's where people sort of go through their trials. And so that stage of learning Rust is called fighting the borrow checker. And once you've learned how to do that well, things change. And I can't count the number of people who said, now that I understand how to program Rust, I go back to my other languages that I also use, and I'm horrified at what I used to write. It's only 2 months ago, right? But I now don't write code the same way in any other language, now that I go back to it. I've heard dozens and dozens of people tell me that. So it's pretty interesting. I keep hitting the wrong button. All right, so Rust will bounce check, say, array accesses by default. If you're running it, if the compiler can determine that you haven't, that you are within bounds, it does know how to elide them, but you can't necessarily, you can't rely on the optimizer being able to do that. That optimization of eliding the bounds check safely is fragile. But if you use iterators and you use like a functional paradigm for iterating, then you won't have any bounce check overhead. A lot of people think that the unsafe keyword in Rust actually turns off the borrow checker. It does not. What it does is it says, I will manually uphold all of the invariants that I must have to have a sound program. But compiler, trust me, I am upholding the invariants. This is not a get out of jail free card. It does not turn off the requirements of writing a safe program. It just puts it on you. And I will also say that that's actually harder than it is, say, writing in C. We can talk about that in Q&A if folks want to go into that anymore. So yeah, we have safe arithmetic. It follows the same rules as C does for arithmetic, but there's no undefined behavior for overflow. I did it again. I guess so. Let me try this one more time. There we go. So I think I talked a little bit about the borrow checker, but the borrow checker is really a way of managing aliases in the program. You cannot see any evidence of the borrow checker in your compiled binary. This is entirely compile time static checking. Once it's made sure everything is good, then there's nothing in the code to indicate that it was borrow checked. So it's truly zero runtime overhead. Okay, I talked a little bit about sync primitives like mutex. It has read, write, lock. It has conditional variables. It's reentrant. There's a lot of things there. It's immutable by default, and that is deep immutability as well. So you can't just get through that. It does channels and other things for memory. It's very suitable for bare metal programming. In fact, we do some bare metal programming in this group. And it's, like I said, it's available as a LLVM toolchain by default, and there's some work ongoing right now for GCC. It has one of the best package managers in the business. They actually modeled it after the stuff that was happening in Ruby and took all the things out they didn't like, right, about the Ruby package manager. Like Ruby, yes, they took a lot of the Ruby out of it. But as a package manager, it's like semver, and it makes sure that you're getting the right, to make sure you're getting the right dependencies. It has some pretty sophisticated dependency resolvers, and there's a lot of C++ developers who are like, forget the language. I actually like it just for the build tools. I would say Rust is a hard language to learn initially. I mean, there's some big brains out there who might disagree, but in general, I think it's a tough language, but I think it's worth it. And in recent years, it's definitely become a lot easier to find Rust developers. And availability of jobs, I think it's hard if you're a junior engineer to find a Rust job. I think they're going to sort of more senior folks, but it's definitely getting easier with all of the FANG companies writing in Rust. There's a lot of strong movement, right, in the Rust direction. And I think that's it. Yep, that's all I have. Thank you. All right, so we've had you guys sitting for a little while, and we have 30 minutes. So we can take like a 2-minute break, or we can go straight into Q&A and use the last bit of time we have with our panel as efficiently as possible. What would you guys like to do? Q&A? All right.
How many people want to go straight to Q&A?
That looks
How many
good.
people need to go pee?
Okay. If you need to go pee, go
Okay,
pee.
you need to go, just do it while we do the Q&A.
All right.
I will actually wander around with a mic so that you can be heard to the folks who are on Teams, because I know we've got like 24 folks there. So if you've got a question, just, you know, throw your meat stick into the air and I will wander over. And while somebody's asking a question, I will be looking for a second one. So who has a question?
Journey on that too.
Thank you. Can I also add a note about C#? Just I think mostly almost everyone was talking about languages more like a runtime plus language rather than language itself. But I think in C# there's powerful features, yield return kind of. So basically it allows lazy kind of processing of data. And also originally it was used also for synchronous processing when you actually can defer and continue execution. So in that case, asynchronous code looks like synchronous, which was later kind of implemented as async await as a kind of second function. But anyway, about the question. So I know it said that I think one thing that nobody touched is about how the language works with LLM, because currently kind of there is like more and more push of using ChatGPT or Gemini or any other models. And so when people, especially junior developers, start using it, they might not like review it properly or do due diligence, etc. And those models, they could make mistakes that people who usually do reviews, who are experienced and do it reviews, they might not expect some mistakes and some errors because of it's not like the person did the mistake, it's just some model generated it. And so it might become hard to actually spot these issues. So I'm wondering whether language can help there with like spotting those kind of issues. It's not just maybe syntax issues, but even logical one, or like issues with business logic and stuff like that.
So summarizing the question, how is the LLM support for the language itself in terms of I'm authoring something in the language? How good is the support I get from an LLM? Is that the question I hear you asking?
How language can help developers to review the code in that language that was generated by LLM?
Yeah.
Or maybe how it can help LLM to generate a better code.
Okay, so from the perspective of how can LLM help a human sort of work through code, Rust is noticeably inferior. Or I should say the LLMs are noticeably inferior at supporting Rust. And I think it's because there's much less training data out there for the LLMs. But I can tell an LLM to do, like, I don't touch the front end web stuff at all, and it just makes it can make a crazy demo with, a web front end, because there's plenty of examples of that. And I can ask it to do something relatively simple in Rust, and plenty of errors. The one redeeming factor I would say is that the Rust compiler is famously strict. And so what'll end up happening is the compiler will reject it. You will not be in a situation where it's almost right and the compiler is like good enough. The compiler is like no. And so if you get into a feedback loop with the LLM, if the LLM can solve it, that's probably your one saving grace.
That begs the question, what about Swift? There's a bunch of Swift examples out there.
So there's a bunch of Swift code out there, and in practice, I've had really good luck trying to get LLMs to write Swift code for me. So I gave a talk here. I'm sorry, somebody else with a similar name to me gave a talk here.
Roughly the same size, same height, same
size.
Yeah.
And
I think I saw that guy.
similar. So you may confuse me with him about his attempts to use Swift with LLMs to write the code for him. And because there's a lot of high quality Swift code out there for the LLMs to scan, the LLMs actually did a pretty good job writing Swift code. Now, there's nothing that the language does itself to make that easy. The thing that the language did was have lots of code out there. So I think the same thing would be true for lots of other languages. There's lots of good code written in your language. You can expect good things. Now, if there's lots of bad code written in your language, you can expect the LLM to regurgitate some of the bad lessons it has learned.
Well, and then Walter, that seems like he's fielding it directly over to you. Amazing.
I've actually tried using LLMs to generate decode, as I mentioned earlier, and I was quite pleasantly surprised at what a good job it did. Not perfect, but it's working. And the other thing I do is if it's not working with D, I ask it to write it in C, and then I take the C code and just change it around a bit as D code.
Okay. You had a question first. I'll be there in a second.
I basically wanted to ask you, talked about Rust having this model sort of to not have backwards compatibility, but still sort of accept or like provide some measures around it. But like for me, for example, I think like there's a reason that a lot of the popular languages do backwards compatibility. C++ has extensive support for backwards compatibility. Google with their Go have extensive support for it. So is there any sort of like movement or any sort of initiative being like proposed to do that or change that in the future? And then my question would be like, can you write different editions of Rust code in the same file? And then I guess the last question.
Okay. One
last question. One last question is, for most of this Rust code I've seen is like, it's very verbose. So how do you even get started with that?
I see. Okay, so I think there's a misunderstanding. I may have not spoken clearly. Rust is forward compatible and backward compatible. So you're getting the best of both worlds. I can write a Rust 2018 module today because that's what my team uses as its coding standard, and we've never updated. But one of our dependencies is a Rust 2024 dependency that we want. No problem, right? And another dependency is a Rust 2015 module. No problem. So it doesn't matter what edition of Rust you're on, and it doesn't matter what edition of Rust your dependencies are on. They all just work, even though the language has changed. In a breaking change kind of way. You can't write this statement in Rust 2018. It does not work. Well, that's okay. My team wouldn't write that. But my dependency has that statement in its module, but that module is marked Rust 2024. And so the compiler will work properly in that domain. So Rust has an advantage over C++ in that there's a degree of flexibility. We can't make any breaking change in the language. There's a limit. To the type of changes that can be made. But there's a huge degree of freedom that most other languages don't have.
Restricted to one edition of Rust.
Yes.
Yeah, it's the same in D. We're implementing editions in a very similar module. And for simplicity's sake, the module declaration sets the edition, and you cannot in the same module have multiple editions. And in fact, I think that would be a terrible idea to have that feature.
I think it's, to be precise for folks there, it's actually at what's called the package level, where you can think of it as Rust calls its chunks of code a crate, but there's some terminology there. But we can just say for general purposes, it's at the level of the dependency itself.
Okay, so I had a little bit to add to the LLM experience with D. I did the first one I did was this is all on Grok. The first one I did was a CPU ID update. D has very nice CPU ID capability, but it's dated. There's it's unbelievable amount of crap behind the scenes that you can get from CPU ID. I mean, it just goes on and on, right? Anyway, so I basically said, okay, Grok, why don't you go write this up for me? And we're going to test it bit for bit in the parts that are compatible with the existing one. Write that unit test too, and just nailed it. And there's just reams of crap coming out of this manual, for all these new pages and all these new bits and all these new fields and all this other stuff. And I'm going, that's great, because I would have a harder time doing it as a human and getting it right than that. So that part's great. And then I went on my next attempt with LLVM. With LLMs was in writing a Vulkan runtime on top of the Vulkan bindings erupted to support dcompute, which is basically a CUDA replacement for D. And I went through 4 top-down iterations in less than a day. So okay, let's just try this one. Okay, how about this one? And then finally got to the 4th one, and I was going through these different ones, and I was realizing I got to a point where I was basically telling it how to edit things. And it's like, no, don't do that. Don't do that. That's a bad idea. So I went through 4 of them. It did fine. And within those, I noticed a few things. First of all, it does fine with index spaces, but not so much with like for each variables or something. It wants to keep index spaces alive. It wants to, the LLMs want to know about things. Also, it sucks at bit fields and bits. It doesn't, its bit logic is just inadequate at this point. It doesn't know it. Right. And so finally, I tried it, backed out of it, and then just wrote it up by hand after those. But it is going to be strange and interesting. I mean, we're living in interesting times, but it is pretty good for LLMs. D is. Oh, last thing, templates. It does very well with generic code. I was very surprised. It does very well with template code.
Okay, next question.
Hi, so I had a question about Rust, but I guess this is probably more generally applicable. I found Rust toolchain to be really, really useful, really seamless in a lot of ways. There are some things I've run into though that are like kind of difficult, especially being that it seems like a lot of times the community kind of waits for these tools, which are like mostly first-party tools, to eventually catch up to their needs. What are for you? What are some of your biggest difficulties with it, and what some of the things that you like most about it? And then for the rest of you, if you want, you can tell me about the toolchain that you use and what you like and don't like about it.
So you're asking like, what's my favorite aspect or most difficult, aspect or least favorite aspect about using the build tool, the build system?
Like you change about
it. Cargo has been fantastic. I would say overall, it's probably the best build tool I've ever used. With that being said, some of the projects I'm working on, or one particular project I'm working on right now, I would like to be able to configure the target from the command line in a very easy way. Obviously, you can do -- target and then put in a target triple and it'll write for whatever code you want. But I want to write custom, right? I want to say I'm writing for this board. And I would like to be able to, in my manifest files, to, like set a feature to be a Raspberry Pi Pico 2W, and I would like the feature to be able to say that's this target, that's this build, that's this way. Cargo has some surprisingly severe limitations on that. And so I've had to go and use a pattern within Cargo called xtask to be able to both stay within Cargo but have the build system work the way I wanted it to, because I was actually rather shocked at how non-orthogonal the features that were implemented in Cargo were. So,
but admit it, you really miss make files, don't you?
I just don't have the words. I don't have the words.
Well, I guess that's a lead in right into MySpace, isn't it?
Pitching you a soft one there, buddy.
So I think in the C++ space, this is the history of that is, decades old, right? And a lot of the concepts that are automatically implemented with, like Rust and some of the more modern languages weren't even thought of, ages ago. Where am I going? Yeah. So that said, I think it'd be nice for the C++ community to have a default install of a tool chain, very much like Rust does, and several other languages. Just simply because, when I'm starting a project in C++, I have to go build all that stuff manually, right? I'm going to use make, or I'm going to use CMake, or I'm going to use a batch file, or whatever the heck it happens to be, right? And then I've got to go get my linter and bring that in. And then I've got to go bring my style analyzer in. And then if I want to use a package manager, I've got to bring that. And each one of these is a separate step. It'd be nice to have just one default, hey, here's something to just get you started, and then you could replace whatever you want later, right? And that, kind of gives you the best of both.
Hey, Donna, are you still on the call? I was going to ask if the CPP2 folks were going down that path at all, but she may have dropped.
Yeah,
there you go.
I'm right here. Sorry. I was just doing some stuff.
That's all right. So talking about build tools, did Herb, when he was talking about CPP2, did he address build tools, or is it still ye old classic makefile?
Yeah, still the old classic build tools from the experiences that I had in analyzing and researching this language. Everything, whether we're talking about bare metal, whether we're talking about, probably iOS, whether we're talking about desktops, what have you. The traditional tool chains are fully supported. And then you have to worry about the transpilation aspect of it. But yeah, tool chains, IDEs, all that is your native C++ environments that everyone knows about.
So is it fair to suggest that what CPP2 is trying to do is be kind of I don't want to say a drop-in replacement, certainly not from a language perspective, but kind of from a tool perspective. You just use it instead of C++, but the rest of the ecosystem is the same?
Yeah. So from what I can tell with CPP2, it's intended, first of all, just to be kind of a skin layer, kind of an abstract, in a way, representation of standard C++, but with the idea of safety and cleaner code being paramount. That's the whole goal from what I can see of what Herb has been trying to do from the inception of this language. Is it's intended to make C++ programming cleaner, probably easier, and maybe even faster to write than the standard C++, using standard C++. That's the whole goal with CPP2.
Cool, thank you. AC on Teams, you have your hand up. Did you have a question?
Yes, while we have Donna, my question is about the Circle compiler, whether CPP front is related to it or how it compares. Sean,
I'm sorry, I didn't quite catch what your question was.
So there is something similar to what you've described, the Circle compiler.
Oh, I'm sorry, but I don't know anything at all. I cannot speak at all about Circle.
Okay, because it was also promoted by Herb Sutter during a conference on stage, so maybe it's related. Thank you.
Well, to be fair, people have been trying to create languages to take C++ down now for what, 20 years?
At least, at least.
I mean, you want to talk about
longer than that.
Here. Yeah, exactly.
Yes. There we go. Yeah, Circle is a distinct effort from CPP front or CPP2. I mean, you can see what CPP2 is designed to be with its original name, right? C front was the original name for C with classes. It's because it's a front end compiler for another compiler. It's not trying to be, it's a new language, at least not yet. And I think CPP front, which is when I got first introduced to it, is trying to do the same thing. Mm-hmm. Circle is another initiative that's trying to take a different approach, right, for building, I believe, again, I may be mixing my C++ replacement languages, but I believe they're trying to build a completely new language that is 100% backward compatible with C++ in terms of its modules. So you can use all your existing C++ code, but you use this new language, for all your new development, if I recall correctly. But that's not her.
And let me jump in on that from yet a slightly different direction too. I'm just going to complete the triad. There's also a language called Carbon, which I cannot think of the person's name, was at Google. And anyway, that's I'll say again. Oh. Okay, so anyway, there's also Carbon, which is another, it's not trying to be necessarily backward compatible. I think there's an interop on it, but that's a kind of the third language that's really trying to be kind of like a next generation C++. For this language panel, we were trying to find a presenter for both Circle and Carbon and didn't come up with one. So
we're going to take here. Oh, in the back.
We got a couple. Yeah, we got hands all over.
You headed that way? Do 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 do.
I might be slightly falling behind, but currently I got an impression that Rust doesn't support inheritance in a sense that we can define a base structure, define some methods for it, and then define derived structure. We inherit from the base, and the base structures methods become available in the derived structure.
Yeah, that's commonly called implementation.
If that's the case, then is there any work happening in that direction in Rust language?
Very clearly that Rust is famously not an object-oriented programming language. So no, there's not any official language work going on in that particular direction, but Rust has a method or a way of accomplishing that. But controversial, but I would say that the language design is coming from a position that OOP generally considered harmful, which is controversial for some folks, yes. And so they have a completely different way of achieving sort of the animal, cat, dog, shape, square, rectangle, hierarchy using a feature called traits in Rust.
Well, part of the thing there too is there's two aspects to this, right? One is, and C++ actually captured this earlier with the difference between public and private inheritance. One is the traditional is-a, right? Cat is an animal, so cat, fully supports the Liskov substitution principle. Cat could be put anywhere an animal is expected. That, in some respects led to these very deeply nested design hierarchies where you had like 47 levels of inheritance, and all of a sudden stuff at the base, fragile base class problem. If I touch anything up there, it ripples throughout the entire system. Java kind of got to that and said, yeah, this is why we're going to create interfaces and you can only have one base class, et cetera. Other languages have said all implementation inheritance is bad. We're not going to do Liskov at all, but we will let you do the private style inheritance where I can say is implemented in terms of, and that's kind of where the trait stuff is going, in the idea that this will make our system more future extensible proof, if that makes sense. There have been a number of languages that have kind of experimented with that before Rust. And so Rust is on, again, it's controversial, particularly to people who grew up in the C++, Java, C# era. And it's not bad, it's just different.
Yeah, having grown up in that world, right? Every language, that came out that was high level was OOP until Rust for me. And of all the things I had to relearn in using Rust, not using OOP wasn't one of them for me. That was actually, it was a smooth transition. There are folks, though, that are writing on the forums trying to do OOP in Rust, and they're having a hard time of it, right? So it's definitely different.
Hey, folks, just one quick interjection. If folks are interested in Carbon, the person driving that's Chandler Carruth. Just took a minute to get the...
Which makes me think what I said about Circle was actually about Carbon and not about Circle.
Oh,
but I don't.
There's so many C++ killer languages out there. It's hard to keep them all straight.
That's right.
Kindle, yes, C++ is dead for the 27th, 28th. Question? There you go.
I'll add to the OOP thing that we could probably have a very interesting panel discussion about what a language thinks OOP is, and get some small talk people to disagree vehemently that Java is object oriented at all.
Insert the Alan Kay quote. I invented the term object oriented, and I can tell you C++ was not what I had in mind.
Yeah, there is a chapter in the Rust book about object-oriented programming in Rust and what Rust does and what Rust doesn't have and how it accomplishes those things and all that. So there seems to be wide agreement among programming languages that like a thing dot with some function that you can call on it that has a receiver is a good thing. But whether you get field inheritance, whether you get implementation inheritance, whether you get infrastructures, whether you need mix-ins to do things instead. Actually, show of hands, whose languages have mix-ins in them that nice. Two other little things I'll just toss out here. For an interesting cross-pollination, Rust has a very experimental, but last I heard, somewhat working backend that actually compiles to the CLR. So there's some people exploring what does it look like to make a assembly in Rust that you could just use straight from your.
Which has some really interesting implications for the whole memory ownership thing. I looked at it back in its infancy, and it's like, oh wow, you guys are taking on some really interesting territory. I'll check back with you in a couple of years.
Yeah, I there's some very scary questions there but all of the C++ CLI stuff, which is yay more random C++ variants, it was using that kind of thing. And just for fun, the joke about, oh God, we clearly should not put multiple editions in the same source file. Rust, you actually can. Not in a good way.
You were going to say that. Look at that look. He's like, oh crap.
There's
the guy.
But in order to make macros from different editions work, the code expands. If I use a macro in my 2024 crate, and the macro comes from a 2015 crate, the code that is generated by the 2015 crate uses the 2015 behavior of what that did instead of 2024 behavior. And I'm very glad I did not have to implement that part.
Oh, macros are spawn of the devil.
Yes.
Anyone who knows me has heard my regular rants against macros, and
Yes.
YD doesn't have macros. But I have another rant I want to take the opportunity to talk about.
Okay,
we've got
you
5
have
minutes.
Okay, show of hands. There's 4 minutes left officially in our time slot. How many people want to hear Walter's rant? How many people want to ask one more question? You have the floor,
Okay.
Walter.
My rant is for all these lazy programming language designers who name their programming language after elements or chemicals. I mean, you should really use imaginative names like a single letter for the name of your programming language, which has the additional benefit of only allowing 26 programming languages to exist. Could be enough for anybody.
Wait. No, only 6 in the English language.
Greek.
Now let's talk about Klingon.
Yeah. Let's talk about Chinese.
and emoji and Unicode. Remember, Mojo can be represented in a single character. It's fire.
Okay.
Why was Go not represented here, Brad?
We did not find a speaker for it. It was on the initial list.
And I already had 2.
And the other one,
But
folks,
I don't really like Go, but
yeah, note that we only had a 2-hour time slot, and we used 75% of it in the languages that we did represent. So we had several constraints around that. So if your favorite language was not here, I apologize. Let us know, and maybe we'll do this again.
Lloyd's fault.
That's right.
Lloyd's fault.
My bad.
Well, thank you, everyone. We do need to leave fairly promptly so the staff can get to go home. Thank you so much. All right. Thank you. That was great. Thank you. Thank you, Dread Pirates. Good to see you. Very well.